Hey everyone, welcome to The Explainer. I am absolutely thrilled you're here today. So, have you ever wondered why an artificial intelligence can crank out a brilliant, highly complex essay in like 2 seconds, but completely loses the plot if you just ask it to watch a 3-minute movie? It's kind of wild, right? Well, today, we are going to decode a really fascinating new research paper that aims to solve exactly that. We're looking at how we can finally teach AI to process audio and video with true human-like reasoning, and it's all thanks to a breakthrough framework called OmniVideo-100K. Okay, let's dive right into this. Here is a quick look at our roadmap. We'll start by diagnosing AI's video problem. Then, we'll explore the OmniVideo solution, breaking it down into Step 1, entity anchoring, and Step 2, clue-guided QA. And finally, we'll look at what this all means for our multimodal AI future. All right, Section 1, AI's video understanding problem, or as I like to call it, the goldfish memory flaw. I want to put this question directly to you. Why does AI struggle so much to understand the movies we watch? I mean, we can seamlessly follow a character's journey from the opening scene all the way to the closing credits. We remember what a character said in minute 1, and we effortlessly apply it to their actions in minute 10. So why can't an AI do this? Well, the answer actually lies in how AI is currently trained to watch videos. When we sit down for a movie, we just seamlessly blend continuous sight and sound, right? But current AI pipelines, they use this completely disconnected approach. Imagine trying to understand a movie if it was chopped up into tiny, isolated 10-second clips, and, get this, the audio was playing in a totally different room. That's exactly what the AI is doing. It processes these modalities in entirely different spaces, so it only ever focuses on short, hyper-localized events. And the consequences of this disconnected processing are, frankly, severe. First off, it severs the inherent associations between sounds and their visual sources. Say a door slams off-screen. The AI struggles to connect that sound to a character's visual reaction. Second, it creates completely incoherent narratives. Because the AI evaluates every single 10-second clip independently, a person in white in segment 1 might be randomly labeled a person with yellow hair in segment 2. The AI literally loses track of the exact same person. It has, you guessed it, goldfish memory. And all of this results in super weak long-term temporal reasoning. The AI simply cannot connect the dots across time. Moving on to Section 2, the OmniVideo solution, a breakthrough data engine. So the crucial point you need to take away here is that OmniVideo-100K is not just some static pile of data. It is a fully automated data engine. It actually takes raw videos and transforms them into structured, entity-anchored scripts. The core goal here is to teach the AI deep cross-modal reasoning, meaning it can finally synergize what it hears with what it sees over really long periods of time, exactly like a human would. Let's look at exactly how it pulls this off. The paper gives us this fantastic visual case study of the engine at work. We're tracking a main entity who they call the brunette girl as she opens these Pop Mart toys. Notice the cycle happening here. Instead of looking at isolated boxes, the system is forming a continuous loop. It extracts her visual features, maps them directly to the audio waveform of her voice, and continuously feeds that data forward. While old AI would look at this and see 3 completely different girls in these distinct segments, OmniVideo's loop tracks her consistently by linking her visual presence directly to the specific audio of her voice. All right, Section 3, let's get into the mechanics. Step 1, entity anchoring, giving AI a continuous memory. The paper details a highly structured process for this. Step 1 is generating a global main entity list. Literally before the video is even chopped up, the AI scans the whole thing to identify the main active entities, like our brunette girl, and creates a unique descriptive identifier for her. Step 2, the video is segmented, but brilliantly, they use speech timestamps as the actual boundaries. This completely prevents cutting off sentences mid-word. Then, Step 3, the AI generates visual captions for each segment, but here's the kicker. It is forced to use that global entity list. Think of it as a foundational memory it just isn't allowed to forget. This guarantees that from minute 3 to minute 7, the AI knows for a fact it's the exact same brunette girl. And finally, Step 4 associates specific speech transcriptions directly to those tracked entities. And this brilliantly illustrates the result. It's a total transformation. We no longer have a messy pile of disconnected 10-second clips. We have a continuous, chronological film strip. It's a structured script that includes a summary, the main entity list, and sequential segments where the audio and visual descriptions are perfectly synchronized on the exact same timeline. Boom. the goldfish memory is cured.
Which brings us to Section 4. Step 2. Clue-guided QA, teaching AI to connect the dots.
Now, the researchers didn't just want the AI to answer super basic questions like, is there a girl present? No way. They wanted deep reasoning. Let's walk through this timeline derived from the paper's framework. The AI is prompted to scan its newly generated script to mine for global clues. At 0 minutes, the summary and entity mapping begins. Down the line, at 3 minutes and 34 seconds, it identifies a crucial audio clue. Then, much later, at 7 minutes and 17 seconds, it identifies a visual clue and an action. The AI literally has to hold on to that early audio clue to understand the later visual outcome. Only then does it generate a complex question and answer pair based on those connected, distant clues. To make this a bit more concrete, let's look at an exact quote from the paper's case study. Around the 3-minute mark, the brunette girl says, "I hope I get one with a Coke bottle instead of a can." 4 minutes later, she opens a toy, and the visual clue shows the toy holding a brown bottle. She says, "I love it." Because the OmniVideo pipeline linked these distant clues across modalities, the AI can now correctly answer why she is happy. It isn't just taking a wild guess. It has an explicit, step-by-step reasoning chain connecting her audio statement at minute 3 directly to the visual object at minute 7. I mean, that is incredibly powerful. Section 5. The multimodal AI future. Validating the OmniVideo impact. So, to prove this methodology actually works outside of theory, the researchers generated a massive data set. Here's a quick overview. We're talking 100,000 automated question and answer pairs sourced from over 5,000 diverse videos. That covers everything from vlogs to news and sports. The videos predominantly span 1 to 3 minutes in length, which ensures that long-term context is actually being tested. The dataset features a 7-to-3 ratio of open-ended to multiple-choice questions. And interestingly, the researchers noted that the word-tailed reasoning chains, not just short, generic conclusions. Finally, they created a rigorous test set of 505 manually reviewed, human-verified samples to ensure absolute factual accuracy and cross-modal dependency. Now, what's really interesting about this slide is this number right here, 20.59%. That is a massive jump. The researchers took existing open-source multimodal large language models, like Vito 1.5 and the QN series models, and they actually fine-tuned them on this new OmniVideo-100K dataset. The performance gains on their human-verified test set were just outstanding. Vito 1.5 saw a staggering 20.59% improvement in its ability to perform advanced reasoning, like causal deduction and timeline wandering. And the reason for those massive gains becomes crystal clear when we look at this comparison. Look at older datasets like AVDS or Music AVQA. OmniVideo-100K is literally a generational leap. As you can see, it is the only dataset that provides complex temporal tasks, explicitly grounds its answers in cross-modal evidence chains, and produces fully structured narratives. Instead of relying on manual annotations or short, decoupled clips, it's forcing the AI to think, remember, and associate exactly like we do. So, what does this all mean for us? We've essentially moved from AI with goldfish memory to AI that can track a narrative thread across time and across senses. As AI learns to see and hear perfectly in sync, linking a whispered hope in minute 1 to a visual triumph in minute 10, what complex human narratives will it be able to understand next? Thank you so much for joining me for this explainer. Keep learning, keep questioning, and I'll catch you next time.